Hello and welcome to my video on mathematical proof. In this video I'll talk to you about what mathematical proof is, why it's really important, some methods and some examples. Okay. Well, why do we need to know mathematical proof? Okay. Let me just give you an example. Right. Suppose you're talking to somebody, friend, family member, doesn't matter who it is, okay, and you say something and then the person you're speaking to then responds with, "Go ahead, prove it." Do you notice immediately how difficult it is sometimes to do that? Okay, you might be able to say quite easily what you believe to be true, but the person you're speaking to might not be convinced, and getting them on board with your idea, trying to prove your idea to them, can actually be extremely difficult. Okay, that just gives you an idea of how challenging mathematical proof is. Okay, but why do we need it? Why do we need mathematical proof? On the board here, I've just written down some examples. Okay, and what I'm going to say is, this first result here, I'm going to hypothesise that the product of two even numbers is an even number. Okay. Now, until it's proved, it's called a conjecture. Some people call it a hypothesis, but mathematically we normally call it a conjecture. Okay. So somebody might have a conjecture that says the product of two even numbers is an even number. Okay. Now, you can't really accept that that's going to work for every single value until it's been proved for you. Okay, it's got to be proved first for every single value before you can go ahead and accept it and use it. Okay, here's the second one. The solution to this quadratic equation, x squared plus bx plus c equals 0, is x equals this. You recognise that as a quadratic formula. Okay, now you've probably been shown that already and you've probably used it lots of times. Has it been proved to you? Have you seen the proof of it? I'm hoping the answer to those questions is yes. If no, then look it up, okay? It's a really fascinating proof. However, the fact of the matter is, you are pleased and happy, well, pleased, that might be the wrong choice of words, I'm pleased anyway. You might be happy to use this, okay, but you could not use it if this did not work for all particular values of a, b and c, okay? The only reason you're happy to go ahead and use it is because there is a mathematical proof proving that this does work for all values of a, b and c. Not just integer values, but fractional values, okay, rational values, okay, but it does actually work, okay. Next one, you probably recognise this as Pythagoras Theorem, okay, so right angle triangle, lengths a, b and c, a squared plus b squared equals c squared, and the converse, you could say that if a squared plus b squared is equal to c squared, then you can put these lengths into a right angle triangle, okay? Again, you've seen this, it's called Pythagoras Theorem, and that's the important word there. A theorem is a result that has been mathematically proved. In other words, this will work for any lengths a, b and c, okay? Obviously, in the context of this, we consider positive values, okay, of a, b and c, but it's been proved to work, okay? And the importance here is you cannot use this result if it has not been proved for every single value, okay? Because it has been proved, then you can go ahead and use it, okay? Now let me just give an example, okay? It is quite easy to use this. Okay? Well, you've got up to this stage, year 12, year 13, so I hope it's quite easy to use this, okay, and get your answer, okay? So for example, if I said that was 3, that was 4, you'd be able to work out quite quickly, that's 5, using Pythagoras Theorem, okay? Similarly, it's quite easy to use this, okay? I could go ahead and give you a quadratic to solve and you'd be able to solve it, okay, quite easy, okay. Proving it is another matter, okay, it's longer to do, okay, and it's more challenging, okay. This one here you might recognise, called Famar's last theorem. Again, the key word there is theorem, it's actually been proved, okay, but pre-1995, okay, a long time ago for some of you, okay, not quite so for people like me, but 1995, before that, this was not a theorem, okay, because it had not been proved, okay. So for hundreds of years, Famar had this result, this conjecture, okay, this hypothesis, if you will, that this was impossible. In other words, x to the n plus y to the n could not be equal to z to the n, for n is greater than 2, such that n is an integer and x, y and z are integers as well. Can I just specify that they should be positive integers? Okay, sorry, I just left that bit on. In the same way as these, we deal with these are positive integers. Now these are all results of theorems and they've been proved to be true, okay? And there's so many more, okay? So many more mathematical theorems, which if you go ahead and use either in mathematics or physics, chemistry, biology, psychology, economics, all the other subjects, okay, that use mathematics. It's called applied mathematics, okay. We go ahead and use those because they're being proved for us, okay. However, if there's a result that doesn't necessarily work for all values, then we'd be quite susceptible, okay. We would think, should we use this or not, okay, because it quite possibly wouldn't work. Okay. Let me just talk a little bit about applied mathematics. Okay, so when we talk about applied mathematics, you might think of mechanics, okay, or statistics, but it's also where you apply mathematics in other scenarios. And I mentioned a few topics just off the top of my head there, where physics, okay, where you apply mathematics quite a lot. Okay, chemistry, biology, economics, psychology, any subject that applies mathematics, okay, you could include in the applies mathematics umbrella, okay. This is about as pure as you can get. So some people ask me what's the difference between pure mathematics and applied mathematics. Pure mathematics, the study of number specifically, okay, although of course in doing that we use algebra as well because it helps in our understanding with the study of number, okay, but this here is about as pure as you can get. Because what we're doing is we're proving these results. We're proving all these results work so that the other specialists, whether it's a physicist or a physician, okay, or a psychologist, so all these other people can actually use our results. They don't need to worry about the proofs of these, okay? A physicist does not need to worry about the proof of a particular theorem. They just want to go ahead and use it. Okay. Just so happens most of the top physicists can actually prove it anyway because they're generally very, very good mathematicians as well. Okay, but that's what a mathematician's job is generally, to be able to come up with these conjectures first of all, and then to be able to prove them so that everyone can actually go ahead and use them. Okay, that just gives you a broad outline of why proof is really, really important. It's thousands and thousands of years old. Okay, and why we study it as well. Okay, but the reason you don't study it really until year 11, 12 and 13 is because it is actually quite challenging. Okay, maybe in a separate video I'll look at that one there. I'll have to think about that. Okay, no way I'm going to cover that. Okay, please, there's no way I'm going to cover that. Okay, ask Sir Andrew Wiles to do that for you, or read one of his books. Okay, this one you've probably seen before. I'm just going to start off with that one. Okay, because it's quite a simple one. Now, just bear in mind when you are doing a proof. Okay, even though it's a simple thing that I'm going to be proving here, you have got to be extremely precise, so precise in what you write down as your, well, I'm going to say solution, your written working, okay? It's actually called a written proof, okay? But you've got to be really precise in what you're doing, okay? So let me just give you an example, hopefully an obvious example of what not to do, okay? So, what I'm going to say is, for example, if I have 4 as one even number, and if I have 12 as another even number, 4 times 12 equals 48. Nowhere near proof, okay? Not even considered, okay? This is what's called a demonstration, an example, okay? It's an example to show how it works, okay? Because some of the more complicated theorems, okay, need explaining, okay? When a teacher's given a new theorem to a class, whether it's Pythagoras Theorem or whether it's going through the Quadratic Formula for the first time, a teacher needs to give examples with actual numbers, okay, so that they are more easily understood. And I'm hoping just by writing this, you can understand what this is saying, okay? The product, meaning multiplication of 2 different even numbers, is an even number. You can see how it works. That's not a proof, is it? Okay. So what we've got to do in a proof is we've got to be able to look back at what we're looking at here. We are looking at even numbers, and the proof is normally done by considering algebra, by considering letters, okay? Using letters to stand for things. Usually use letter N to stand for a number, obviously, and M, just because they're consecutive in the alphabet. So M and N are generally used, okay, in this sort of example, okay? However, it's no good just saying let M be a particular number, okay? Because M could be odd, it could be even, it could be rational, it could be irrational, it could be complex, for goodness sake. Okay? You've got to be able to define what N is. It's no good to be able to say either let M be an even integer. Okay, you've got to define it even more precise than that. What do we mean by an even number? We mean that you have an integer, that's a whole number, that's multiplied by 2. Okay, and so what we'll say is we'll let 2m, okay, be an even number, okay, let me just write it down, be an even number, where I've got to define what m is. And in a mathematical proof, whenever you introduce a new letter, you have to define what that letter stands for, okay? So I'm going to say where m is an integer. Let's go check the question. It doesn't say anything about positive or negative, it just says even numbers, okay? You need to know what these symbols are, okay? So Z, like this, okay? Blackboard, bold, Z, whatever you want to call it, okay, is the set of integers, okay? So m, okay, is an integer, and therefore 2m is an even number, okay? It says the product of two even numbers, okay? Now you've got to introduce a completely different even number. It doesn't mean the next even number, okay? So notice my example, I didn't have two consecutive even numbers, did I? Okay? So I'm going to introduce another even number. So 2n is another even number. Okay, and I've introduced a new letter again, so I've got defined for you what that n stands for. Okay, so where n also is an integer. So I've got my two even numbers now, I've got 2m and 2n, okay? So that is this bit here. I've defined it, I've taken that part of this sentence and I've defined what the two even numbers are. And then I'm going to take the product of them, okay? So I'm going to do 2m multiplied by 2n. You don't need brackets because obviously 2m means 2 times n and 2 times n there, and so you've got 2 times n. If you want to make it absolutely clear, you can do that if you wish, but there's no need, okay? And then we're going to write down what that is, okay? And quite easily, 2 times 2 is 4, and you've got m times n, which is that. So that's the algebraic working done, okay? Can you see that is also obviously an even number, okay? But we've got to explain why it is obviously an even number, okay? And then the way I'm going to do that is to write it like this. That's the same as 2 multiplied by, let's just put it in brackets, 2mn. The brackets are not really necessary, okay? And then I'm going to conclude which is an even number. Generally we just say which is even, and then I'm going to explain why it's even, okay? And I'm going to say since, because it's shorter to write than because, okay, which is even since 2mn is an integer, okay? And we can say that because of a previous theorem, which is you multiply two different integers together, you get another integer, okay? I'm not going to prove that one for you, but the idea here is that you are allowed to use previously proved results, other theorems, to help you to prove this result here, okay? And then it's done, okay? I'm just going to mention the highlights of this proof for you, okay? So we've got the statement there, okay? It might be called a conjecture. We know it's a theorem because it's been proved, okay? But initially it might be called a conjecture, okay? What you do is define the key items within this, okay? The key values. That is, we need to define what we mean by an even number, and there are two of them, okay? Whenever any new letters introduced, you have to state what they stand for, okay? And then you've got to go ahead and try and work out, you know, whether this is true or not. It's the product, so multiply them together, do any mathematical work and that's necessary, and then explain clearly why this is an even number, okay? Remember, we define even numbers being 2 multiplied by another integer, okay? And since we can write it as 2 times an integer, then it must be an even number, okay? If you take out some of these steps, it's not a complete proof, okay? So let me just say, if I take out this bit here, I don't want to rub it off because it makes it incomplete, and if someone just comes into the video too late, you know, just fast forwards and those bits are missing, they're going to say, oh, he's not very good, is he? Because he's missed out these important steps. So, but just imagine that these aren't there, okay? I rarely get to stand on this side of the board. How is it? How is it when I stay on this side of the board, okay? If I was left-handed, you know, this is exactly how my lessons would actually look, okay? But I'm not. If it looked like that, okay, and I presented to someone, this is my proof, a mathematician would first of all say, well, that's not a proof, is it? Because suppose m is a irrational number, for example. It doesn't work, okay? Because I've not defined what m is. So it's important, much better, it's important for me to define what I mean by this letter m, okay? And what I mean by this letter m. I'm hoping that was a good enough introduction for you, okay? I'm hoping that gives you a good idea of what a proof is, why it's really important, the challenges, okay? And, you know, as I said, why it's our job as mathematicians to be able to prove the results so that they can be applied elsewhere in the world. Okay.